Hello, welcome. We're going to continue our discussion of flow rates. So it looks like a lot of words, but I just write really big and it's like only 2 or 3 sentences. But let's dissect this and take out the necessary pieces of information. So we have a molar flow rate of 500 kilomoles per second, and it has 3 components, C, H, and E. Okay, and we're given the mole percentage of C, 16 mole percent, and the mole percentage of H. And we're also given the molar mass components for the molar mass for each component. So for component C, component H, and component E, we have the 3 molar masses here, respectively. And we want to calculate the mass flow rate in kilograms per second of each component, and we also want to calculate the total mass flow rate of the solution in grams per second. So units are very important. Okay, so just as we go from moles to mass, we can go from molar flow rate to mass flow rate with the conversion grams per mole. So it's a good thing they provided those smaller mass values. So let's write out what we know. The molar flow rate is 500 kilomoles per second, and we're given the percentages of the components. We know that the solution is 16% C and 62% H. So with this, we can see that the molar flow rate of component C is 80 kilomoles of C per second, and similarly 62% of 500, that means the molar flow rate of H is 310 kilomoles of H per second. And they said there's 3 components, C, H, and E. So out of 100%, we know that 22% is remaining from E. Even though this information was not provided, we can figure it out from the other 2 components. And 22% of 500 is 110 kilomoles of E per second. So what we're going to be doing is converting each of these molar flow rates to mass flow rates with our convenient molar mass conversions. So the values provided here, they told us 170, 250, and 80 grams per mole, so we can fill that in. And another thing, instead of writing grams per mole, we can write kilograms per kilomole. And we're allowed to do this because grams per mole, if you multiply both the top and the bottom by the same units, then it'll not change. Okay, and what do we get for each of these? The resulting flow rates are 13,600, 77,500, and 8,800. And if we write all this out with our notation, we'll write M for the mass flow rate with a dot above it, and the subscript C indicates the mass flow rate of component C is 13,600 kilograms of C per second. The mass flow rate of H is 77,500 kilograms of H per second, and the mass flow rate of E is 8,800 kilograms of E per second. And I like to rewrite them and provide this notation and also have all the answers together so they can be found conveniently for the grader or whoever is checking this. And lastly, the total mass flow rate, capital M, is just going to be all of these added up together. And when we do that, we get 99,900 kilograms per second. But we want it in grams per second. So we need to make that conversion from kilograms per second to grams per second. We're going to need to multiply by 10 to the third power, and that'll give us the correct units. So writing this out in scientific notation, because there's a lot of zeros, we have 99.9 times 10 to the 6th grams per second. And that is the total mass flow rate of the solution. Alright, hopefully you found this helpful, and if so, please check out the other videos or leave a comment below.